welcome to Flat Earth Debate Uncut and After Show. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they premiere, and there's also a PayPal, Patreon and crypto link in the info box below the video. Also below this video you can get £50 for swapping your UK electricity supplier to Octopus Energy, and this is of particular note if you drive an electric vehicle. Speaking of patrons, I'm going to do a quick shout out to all of you who do support me on Patreon. So a massive shout out of thanks and appreciation to Sarah Griffiths, Rob H, Ben White, Maximum Gravy, Austin Whitsitt, John Kays, Tommy Swagnuts, Michael Kahn, Patrick Gunnels, Banter, Will Brax, Mel B. Styles, Troy Shuker, Bose Nail, Samson, Maris, Hairy Blade, Mobile Mac 777, Neo the One, Lost Cat FE, Rob W, Open Minded, Reese Pound, Dal West Watson, Mike, Muted, Dick Earth Skeptic, Maria Neelands, Unbelievable Productions, Blue Ridge Ranger, The Real Gabster, Liam Nedrick Jr., Abraham Mohammed, Adrian Quintana, Skeptic936, Life is Short, theflatearthchannel.com, Texas Mike, and David Wayne Foster. So another massive thank you to all of you for supporting me on Patreon. Now I will hand over to whoever is in Discord and Google so you can enjoy their dulcet tones while I set up for today's live show. Hey, Ten.
Yeah, Moses used to sell them all to the Israelites before they fasted.
Good morning.
Hey, you don't have to try it with magnesium. You can do it without if you want. But I drink like distilled water during a fast, so I don't get like minerals. Distilled water, right? And magnesium is a mineral. It also helped with like my muscles. They were like starting to feel like I needed to put A535 on them and stuff like that. I started feeling really weird and I was getting really like restless and uncomfortable. So when I took the magnesium, that also fixed that.
Yeah.
The most I did when I was going to Times Square Church, you know, the whole church would fast the full 3 days. And here's a little advice. Don't ever break a 3-day fast and eat a Big Mac meal.
Talk to a wrestler.
Yes, Wendy's, Burger King, that's all fine.
Oh yeah, I had Burger King
Well,
one time after like
I
a
ate
more than
big-
3-day fast. I had a
I
burger and a
happened-
poutine and the works.
I had a Big Mac meal with the fries, and I think I even put a shake on top of it.
Oh gosh.
And I felt like I was going to explode. Pain in my stomach. It was horrible.
Talk to a wrestler. I did it. I had to lose weight in high school, lots of weight, each week. And the day of the match, they weigh you, say it's a Saturday match. Or if it's at in your league match, it'll be on a Friday or a Thursday. And right after you weigh in, you can eat, but you haven't ate for a week. I mean, sucking on ice cubes and losing 15 pounds in a week. And then all of a sudden you're about to go into a match a couple hours later, maybe an hour, 45 minutes later, you need energy. So what do? You can't go eat a hamburger. Your stomach shrunk.
I got a funny story. When I was in Rikers Island, I think I was doing a 10-month violation, parole violation. Anyway, I was on the maintenance crew, so I could get out of the cell and, you know, roam around the prison. So you get a little job like that. And I was, again, this is the first time I tried to fast. I just got into Christianity, so I wanted to go all the way. So I'm fasting, but I was drinking like the little things of 2% milk. And I'm doing maintenance, and all of a sudden, I felt something in my stomach. So I thought, all right, I gotta let one go here. And next thing I know, it went all
I
right.
don't care. Don't want to hear. Don't want to hear. Not interested.
Anyway, the walk back was, I was doing a duck walk back. And the officers were like, what's going on? I said, I gotta get to my cell.
Such colorful stories, Neil. Have some restraint.
Come on, the president just shit his pants.
Oh, gosh.
Just can we change the subject, please?
Yeah, thank you.
To what? Vomiting? Just kidding.
Yeah, Neil, go on mute.
Did you ever see the movie The Pope of Greenwich Village? With Eric Roberts and Mickey Rourke? Anyway, the cop, they go to meet this guy because they're cracking into a safe. And this cop is a real idiot in the Bronx. And he has Eric Roberts' car towed. He ran out and he wouldn't even let him go. So the next time he goes back, he sees the cop in the bar. But he remembers that the bartender said, yeah, that cop gets everybody. He comes in here every day and he has a drink for free. So Eric Roberts keeps that in his mind, and he goes back a couple of weeks later, whatever it is. And the cop goes in the bar, but he goes to use the toilet. And when he went to use the toilet, Eric Roberts slipped a Mickey in his drink, but it was a horse laxative. And it's hysterical after that. You got to see the movie.
Why did it find its way back to that topic?
Yeah, and why were they crapping into a safe? This is a horrible story.
It's a Pope of Greenwich Village. It's about two guys from Greenwich Village that robbed the local mafia's safe and wound up, paying the price.
So they
Watch
crapped
the
in it.
movie. It's a cult classic. Well, that's one of the good scenes where he gets the cop back. And he's running through the Bronx saying, cop shit his pants. Because, he gave horse laxative to him.
Nathan, I'm going to share my screen to share a few slides.
Oh, excellent. Let's escape from this Adam Sandler movie.
Thank you.
Oh, my God. You guys are babies.
You see it?
See a boat. Very nice boat.
Yeah. You got it all in frame, or got the whole picture? Hello.
Yes, it looks good. It looks good.
Okay, perfect. Okay, I didn't hear you. So this is from Mitchell. He's going to be interviewing Brian from Brian's Logic today. And he shared these slides. And I said, I'll share them in the pre-show tomorrow. And he makes good slides, by the way.
Stop one
so
second.
here's
right, hold on. Just start again. But either turn your gain down on your mic. I kept meaning to interrupt you all through yesterday's show. On your Yeti, just turn the gain down 2 or 3 notches.
It is.
Is it?
It's all. I just got to move it farther away, maybe. Let me see. How's that?
That's
Is that better?
Yeah, you're
Okay.
just overloading it a little bit, and it's just a bit nasty.
I'm sorry.
A bit crunchy. Start again.
All right. So Mitchell from Australia is going to be having a show today with Brian Logic, and he was using these slides on yesterday's show. And so I said, hey, send me those slides and I'll share them in the pre-show, because I'm sure you and Brian are going to go over it. So kind of like a teaser. So here's a boat in the ocean, and there's a sun somewhere over the ocean, and it's got a zenith position to a GP, so a 90 degree somewhere far off. And Mitchell put the sextant as if the navigator from this height from the ocean surface is going to shoot the star. So the next slide will show what's actually taking place with the sextant. Because you got to understand, it's an angle measuring device. And this is what the ballers don't get. Now, I can't help it that they've been deceived, because they've taken the angle measuring device and always portray it on a globe. but it's silly because it's an angle measuring device, and it's measuring a right angle with a 90 degree so that you can triangulate. So you need to get this precise angle measuring device down here because you're up there. And you can't do this from there, but you can adjust it as if you're doing it from here so that you can do it to the surface of the Earth in reality, which is a plane. So, because when you shoot the sextant high above the ocean floor, surface, excuse me, you're going to have this. So this is what dip correction is. It's the height of your eye in this telescope having to be brought down to the surface of the ocean so that this angle could be achieved. If you go this way, depending how high you are and you do not do dip correction, then you're going to be off of your target. Okay? So like if you're 10 feet above the water and you don't do dip correction, you're going to be 3 miles or more off. Well, no one wants to be 3 miles or more off because the tool is a precise tool. So use it as instructed. So what you do is you take it from there, but then you adjust for the height and match the plane of the Earth. So now you have a precise right angle, and you know exactly by this angle right here how far you are, because you're going to times that to the nautical miles and get your distance here. So this is exactly what's happening in the picture view with dip. It's just your eye having to come to the surface of the water because you're not going to jump overboard to take the measurement. You're going to do it in a comfortable place. And then it also validates your zenith because directly above you to the ocean is your GP. So here's your GP, here's the sun's GP, and the distance in between is a flat baseline because the sextant is an angle measuring device. This is so simple to understand, but since the deception has been to get this tool to somehow match up with a globe, when the tool itself can work with a curved surface, this is the discovery of 2021 in bright lights, you know, so to speak, almost like a brand new movie coming out, and then you just put it out there. You said, look, the sextant's an angle measuring device. It cannot work with a curved surface. And so all of a sudden the ballers are like, no, celestial navigation, you're going to need a globe for that. Oh, the long play worked. They fell into the biggest trap. Because once you start studying the sextant on your own, audience, you're going to find out it needs this right angle. That means you need a flat baseline. That means when they say in the instructions, dip correction, it's always a subtractive correction. You never add dip, you subtract dip. Why? Because you're here and you need to be here. What happens when you do this from here? It's a straight beeline right there. That means the GP of the star or sun and you is flat and everything in between. Any questions?
No, I did see this on Mitch's. Very good. I like these slides. Putting the boat right on the horizon makes it so much more easy to visualize.
Well, it's not Muppet vision. It's the way you see through a sextant. Because when you look through a sextant, you're looking this way to the horizon. Now, because you're using the natural sea horizon, you take a dip. Because you're using the natural sea horizon. But what are you doing? All you're doing is bringing your eye to the water line so you can match what? Reality.
That makes sense to take a dip when you're in the ocean. I agree.
Oh, very nice, Neil. I'm going to get off of here, and if you can go to Master B, and we'll go through those slides, and I'll be done. Do you see the slides in Master B, Nathan?
Yeah, just give me a second.
Yeah, me too. Hold on. I
was going to.
Yeah, go on.
Like the orthographic view in itself isn't a bad thing to say. You know, like we've labeled it Muppet vision because they use a flat Earth to try to derive a curve in orthographic. But you know, as long as you recognize that the world's flat, I don't see any problem with orthographic.
We don't call it
Yeah, but they
Muppet
always-
Vision. Sorry, we don't call it Muppet Vision because whatever you just said. It's because you see the side of your own head. If you look at the
Yeah,
the
like if you're trying to lay down a geometric principle, right? I don't see any problem with it.
no,
As long as you're not
yeah,
saying
exactly. If it's geometric, then what's the problem? Well, none, because you're not taking optics into account. That was the very justification we got 4 years ago when we were doing the Isle of Man debate. Well, what about optics? Don't need to worry about optics. It's geometric only. Don't need optics. That's what they told us, and you're right. Who's making that bloody racket while I've got... Can't see who's doing it to tell them
I
off.
was moving my phone, sorry.
Bloody hellfire.
Sound Nazis on board. Be careful.
Yeah, I was just pointing out the argument, how it's changed. You know, like we're pointing out pure geometry and they're denying it. And never mind, it was funny to me.
No, it makes
All right,
perfect sense. The arguments come full circle, and it's amusing because you've gone from them making a geometric assertion, don't need optics because of it, to them making a refracted, non-geometric, but based on a geometric R value that can't be derived paradoxically if you refract the horizon geometry, to a flat only, can only be flat to derive two straight lines geometry, that according to Arwin's description of it by way of Baldwin, you've got, let's see if I can get this right, an apparent flat surface presented to you by courtesy of R-based terrestrial refraction, so that you can take the apparent refracted, formerly geometric, now paradoxically refracted with R, apparently flat seeming horizon to give you the angle. You know what I mean? I think that was pretty good. That was a pretty good summary, wouldn't you agree? Nobody followed that summary. That was terrible, Nathan.
Yes, Nathan, great one.
I'm scared to come off mute.
So you should be
Yeah,
Mr.
but-
Scratchy Mike.
But what I'm saying though is now we're the ones making geometric claims. Or well, you guys are. I'm sort of like a third party observer at this point. But now before it was them saying, you know, oh, this is just a purely geometric claim about the horizon. And y'all were pointing out it was Muppet Vision, right? And now 10th is laying down that the sextant is used to measure geometry and demonstrating that geometrically. And they're not wanting to deal with it. It's hilarious.
Yes, it's the same with science. Now we're doing it with maths. So a couple of years ago, maybe a bit longer actually, the whole globe shtick was to say that the whole body of science proves we're on a sphere. That was their shtick. Hey, Brian, by the way. Now science doesn't prove anything. It's open to change after the fact. It's like, oh, right. Yeah, your pseudoscience that you claimed was proving the globe is open to change. Yeah, definitely, because it's not a globe. It's actually flat. That's your change in your pseudoscience. Meanwhile, science definitely does prove things. Now, in terms of geometry, there are certain principles that you can apply. Bev's show, I don't know if you watch that much, John. Do you watch much of Bev? What about you, Brian? Or 10th, for that matter? Or Neil?
I do. Yeah, Bendy's Arnold's hilarious.
Oh, he just drags them around by their short hairs, don't he? Just talking about geometry. That's all he does. It's brilliant. Love it. But they don't want to deal with
He's
it
been
now.
doing that. He's been doing that for a while, though.
Yeah.
Shortly after I converted with the Black Swan, I started watching Bev. So yeah.
Hello.
Hello.
I don't agree with everything he says. Like when he, the one thing he says about the Black Swan and saying that you're begging the question, you know, and that's a flaw within the argument.
What? Yeah, no shit. Assuming that the Earth's a sphere in the first premise is the begging the question fallacy we're having to get into to debunk it within the begging the question fallacy. Because after pointing out that our assumption is begging the question, they said, yeah, we will. So we had to get into begging the question on their behalf to show how even when you beg the question of a sphere Earth radius 3959, that's their claim, it doesn't match up with the actual geometry that you're measuring because, according to them, it's refracted. So not geometric anymore. I don't see what the issue is. I don't see why Bev wouldn't appreciate that. But yeah, I've seen him say the same things. I don't get into it though. You know, that doesn't concern me. What he does do in terms of what he makes in terms of geometric claims are often along the exact same lines anyway. So maybe it's jealousy. I don't know.
Right. Yeah. He still smashes them with the geometry. That's
Exactly.
That's an interesting to watch.
That's all I'm concerned about. Does he drag them around by their short hairs? Tick. Yes, he does. So beyond that, does anybody really care? If you're slagging me off, I don't care. Arwin does it in my own chat, and then you all like white knights what might be off. It's like, I don't care. Do what you like. I don't really care.
But even still, it's not our argument anyway. I mean, our claim anyway that the Earth is a sphere. We're just using their claim.
Exactly. We're not begging the question. We're forced to beg their question to take it apart with modus tollens. So we're taking apart a positive claim. That's them begging the question. But yeah, no shit. We've been pointing that out for about 4 years. Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon and crypto link in the info box below the video. Also below this video, you can get £50 for swapping your UK electricity supplier to Octopus Energy, and this is a particular note if you drive an electric vehicle. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected. And if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show on Facebook and Twitter. One last time, if you're new to the channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. Now, we are joined by Neil, Arwin, 10th Man, Refracted Curvature, Brian's Logic, and a whole bunch of people in Discord. So welcome, one and all.
Hello, everyone. Good afternoon.
Hey, hey.
Hello, good morning.
How are you?
Very well. Good to have an enthusiasm level beyond about 10% from Discord. Excellent. Good to see it. Any scientific evidence of gravity?
Nothing to see here.
What is it?
There is nothing to
They
see here,
can't
Arwin, when you say
define
what
the
is it? There's nothing to
phenomenon.
see. Go ahead from Discord.
Yeah, they can't even define the phenomenon.
If you use Einstein's description, what is space-time bending around? That would be a problem of R.
Yeah, you're going to need R for
How
that.
do you vary and manipulate it?
Yeah, the application of Einstein's gravity is going to need an R value, that's right. The gravity itself with Einstein doesn't need R, but the application does, you're right.
Come on, Alwyn, you can't get around that.
Around? What, with an R value? You'll need an R value to get around that, Neil.
Yeah, you already answered it by saying around. There you go, there's the R value.
Any evidence of the R value, Earth radius?
Can't get around that either.
Well, if they calculate it to account for the radius, then it must exist. So geodesics exist.
Calculate
Therefore,
it
there must be a
without
radius.
first presupposing the sphere.
Hold on, didn't John just cover that like 25 seconds ago? What's this geodesic in space-time bending around again, Arwin? When we're trying to establish where you're getting R value from, and it was covered 35 seconds ago?
Now, I'm currently making a stand, making the fuel argument, basically, right? Geodesics exist, so why would it exist if there was no radius?
What? That's a nice positioning of why wouldn't my fantasy exist if I didn't have a radius I can't measure? I don't know, who cares? You haven't got one, and we haven't got fourth dimensional space-time bending around one that you haven't got either, as just pointed out about a minute ago by John. Do you want to run it by him again, John? Maybe not.
Was I there?
What is space-time bending around if you can't measure the R value?
Well, that shut him up. Nice. So, moving on.
Well, why is it bending around? Why
Don't
you're
ask
asking
me.
what it
Don't
is
ask
bending
him.
around? If it is bending around, you got something that's round.
Sorry.
The bending is.
Sorry, if you've got something that's round, Mr. Burden-proof reversal fallacy.
Yeah.
Yeah, this
agreed.
is your claim to prove if you're going to be Baldwin.
There has to be unicorns.
I just
got a bunch
agree.
of books on them.
You said there's got to be something to bend around if we're bending around something. Well, no, we're pointing out we haven't got fourth-dimensional geodesics in space-time bending around anything, and if you did, you'd need an R value for it. But you're saying, well, yeah, but if we are bending... No. Then you're trying to reverse that and say, if you've got something bending... No, I haven't got anything. I haven't got reference frames either. Can we move on? Any evidence of...
Things can bend around nothing, too.
What?
Just because something is bending around doesn't mean that it automatically implies there is something in there that it is bending around. It's just getting very convoluted, sorry.
What, like a rubber band can bend around the air?
Yeah.
Just talking nonsense. He's been in Fantasyland on his own show today.
I was?
Yeah, you were talking about D&D towards the end, and I had to rewind, because I was like, my God, because my wife collared me. She's like, what is Arwin babbling on about with his derper nonsense? Those were her exact words. And I listened, and I was like, my God, he is talking a lot of crap. So I rewound, and then realised you were talking about concepts within Dungeons and Dragons, and you were just transposing on various different aspects of things like Narnia. I was like, oh, and then I explained it. And you're like, oh, okay.
Oh, right.
So you're not...
That part, yeah.
Well, because I'd been vacuuming. I just tuned in halfway through when I hadn't been paying attention. Suddenly it sounded like you were off in La La Land for anybody that just tuned in at that moment. Me and my wife in this instance. Literally, it was like, what the hell? Has Owen gone nuts? No. It's just talking about Dungeons and Dragons and comparing it to Narnia and then comparing it to holographic Sun and Moon is where I sort of rewound and started to get an idea of how you were doing what you were doing. But like I say, I'll just have you on in the background when I'm tidying up before the show.
Right, and then I ended up with Peter Pan going to the moon, but ending up in Never Neverland.
Yeah, let's not poison my audience with this shite. Any single viable hypothesis from any of the fields of astronomy, cosmology, or astrophysics?
If a heliocentrist wanted to put forth a hypothesis, I'm pretty sure they would have R in it, wouldn't they?
To do with the heliocentric model, yeah, they'd absolutely require it.
According to my son, they're doing something because they know the sun is plasma. So they got to be doing something.
What? Because they know... Well, we know there's unicorns out there. And because we know they're unicorns, they've got to be doing something with the unicorns. Because they're talking about how we've got unicorns, so they're doing something.
That's flawed logic.
Okay. Any evidence of axial rotation of the Earth-based variety?
In the heliocentric model, you wouldn't expect the gas to not move in lockstep rotation with the Earth.
Well, that would be no drift then.
Yes.
Yeah, the globe claims that we've got 15 degrees an hour drift as Earth turns beneath things that aren't attached. It's called Coriolis effect. So, I don't really understand. I mean, I realise that there's lots of anti-flat earthers out there that like to tell us how they can justify us not seeing drift that we don't claim we should, but the globe does. At 15 degrees an hour observed from the ground as you turn beneath things, as is claimed by the globe, and we don't observe. So, I don't know, you can detail how we won't observe it and why we won't observe it, but it doesn't seem of much use.
Well, it's because of the columns of air weighing down on Earth that it gets dragged around and basically attains momentum.
That's the conservation of angular momentum is what you're describing, right?
Yes, based on the realization that gas on a spinning ball Earth going down, go boom boom, and forming columns will actually be susceptible by momentum by the presupposed nature of all that.
That still requires a radius.
And it requires gas go down, go boom boom.
Yeah, and gas pressure not expanding in all directions to fill the available volume.
And gas pressure without a container. Any evidence that you can have gas pressure without a container?
Even if you could measure a radius, that would still be impossible.
Okay, after this I'm gonna stop, but gas moving in lockstep with the rotation of the Earth proves.
Can you stop?
Gas
You're
pressure
upsetting
without a
Brian.
container.
This is bad. It's really bad.
I know.
So no drift then.
No.
So yeah. When you do it as Baldwin, yeah, there's this highlighting, which is beautiful, of the fact that what you're actually doing is debunking the globe claims of drift. Now, I realise that there are many inexperienced flat earthers who debate the subject of Earth turn with people and then end up defending how globe claims should be in effect with drift because they don't realise when they're having the burn the proof reversal fallacy employed. But when you go, Arwin, straight to the anti-flat Earth, we wouldn't expect to see drift. We've got lockstep atmosphere, sphere-shaped air moving with a presupposed spherical Earth that's turning, giving us no net effect to observe. You're essentially debunking the actual globe claim that would be that we will see drift.
Yes.
So anti-flat earthers listening, when you point out how Earth will travel in lockstep with its own atmosphere as you presuppose it turns, what you're doing is you're debunking the globe's claim of drift at 15 degrees an hour. Of course, if we did have 15 degrees an hour drift, as the globe claims, then flight times would be shortened as a net consequence of you observing them seem to drift as you turn beneath them, because it means you're turning beneath aircraft, and therefore their flight times would be shortened when travelling west.
Could I say something quick on it? That
Feel
I said, I think it was yesterday.
Yeah, feel
Thanks.
free.
Well, even in the fantasy of a gas that forms a sphere around a sphere next to a vacuum, even in that fantasy of lockstep air moving with a rotating globe out, which would mean a 15 degree an hour rotation of all the gas. Even in that fantasy, to fly from North Carolina to Los Angeles, you have to fly through the air. So that means you have to fly against the rotation of a globe out in that fantasy. So that still wouldn't change anything. You still should be an hour and a half, only an hour and a half as opposed to 4 hours or whatever, getting to Los Angeles because you're flying against the rotation of the globe out, because you're still flying through air. Otherwise, when you took off an hour and a half later, 5 hours later, 12 hours later, you're still going to be in North Carolina if you're moving with lockstep air. If you're not flying through the air, then you're not going anywhere. So your claim is complete and utter rubbish.
Not their claim, their rebuttal to our debunking of the globe claim that we should see drift from the ground. So globe claims we should see drift from the ground, that's 15 degrees an hour, deviation called Coriolis effect. If we see drift at 15 degrees an hour from a turning reference frame that would be claimed to be an Earth that's turning, then flight times would be reduced. We point out that we don't have reduced flight times, we're not observing drift. The anti-flat Earth rebuttal to that, not the claim, sorry to cut you off, Brian, is that we wouldn't expect to see the drift the globe's claiming because we've got lockstep atmosphere moving with a presupposed moving Earth that gives us no net effect.
So you're right, Nathan.
Right.
It's not the official globe claim. It's the claim we deal with mostly. That the only thing I'm pointing out is it doesn't matter. Either of those claims means that there has to be a flight from North Carolina to Los Angeles that will only take an hour and a half, and a flight the other direction that should take never, because it can never catch up with the rotation. So the fact that that doesn't happen means, if A then B, not A then not B kind of situation, isn't it?
Yeah, this has actually been done, so I'm not going to take any credit for this modus tollens argument, but you're correct. So if Earth is turning, we will observe Coriolis effect. Now that isn't me begging the question, any anti-flat earthers, or globe believers out there. That is me asserting the globe claim that if Earth turns, we will see Coriolis deflection. If A, then B. No Coriolis deflection, therefore no Earth turning. It is just that simple.
Can I say something? I don't want to be a dick, but I agree on the technicality, because that point is based on the assumption that everything within the medium is actually much closer to physical reality as we know it, right? But if gas wouldn't basically be gas as we know it, but be that weight thing that's going down in columns, then that kind of wouldn't happen, because everything would just be carried along with it, like as if it were water.
Yeah,
Right? If the whole thing is lockstep moving, there's not going to be a difference. But that's all based on the crazy anti-flat Earth assumptions of how gas in that model works.
What, go down, go boom, boom?
Time to really even consider it, because it's not even close to the physical reality that we know, in which gas would not be susceptible by momentum in any way. Right?
Yeah, well, that's what Brian's saying. If the water that you're describing by analogy as the air moving along with the ground that's also moving, that's Brian's point. You're not going to go anywhere. You've got to go through the air. Likewise, if you've got a fish tank on a merry-go-round, right, you're not moving anywhere relative to the fish tank. That's the air that you're in, if you're comparing it in that way. You've got to actually still swim through the water.
Hold on, I have a add-on.
Did you say Brian Allergy?
No.
Like
That could be what it was called, though. I like it.
That's a good one.
I have an add-on to the rebellious gas particles story.
Oh, well, someone's got to say... that's great.
Line.
Hold on. If you can remember it, because someone else has got to summarise it. Normally I'd lean on chocolate here, but it's not. So who's going to summarise the story of the rebellious gas particles up until John's add-on, and then you can add it on for the audience's benefit who's not new.
You
are new.
If you want.
Yeah, go ahead, Brian.
Yeah, it's that there was a group of gas particles that were behaving as gas particles always do, which means to continue expanding out into their every available volume. But when they got to the Kármán line, there's a group of them just said, no, we're not doing this. They rebelled against it. They threw away their bras. And that was that. They said, I'm not moving past the Kármán line. That's it.
Okay, no, there's more to the story than that. Obviously, they started to clump together at the Kármán line, but because they weren't expanding in all directions in violation of natural law, having burned their bras, they all started to eat cake, get very fat, and then they started to go down, go boom, boom.
Sorry, yeah.
But see, that's not all they did either, because they realized that the Earth was turning underneath them, so they started to run to catch back up with the place that they left from. See, that's in their conscious awareness of the ground that was below them. They realized that it had moved, so they had to run to catch back up with it.
Oh, I see. I gotcha.
Oh, just like the orbits of the solar system.
No, it's homesickness. So what happened was they've burnt their bras. Some of them have decided, I'm just going to give up on life, get fat, and then go down, go boom, boom, because that's what I'm going to have to do because I've got a lot of weight now, because that's how it works with gas. Anyway, lots of cake eating, they go down. But some of them you're right. Some of them recognise that, actually, look at that. Below me, my home, wherever it may be for me, the UK, look at that, it's whipping away from me. Oh my God, you know what I'm going to do? I'm going to go a bit faster than it's going because I'm higher than it, so I can keep up. That's right, that's exactly what some of them consciously decided to do. They're going to keep up with the ground that they're not bonded to anymore because they are bonded to it through homesickness. So obviously if they were produced in the lakes of the UK, they're going to want to hover over that particular lake, aren't they? It's home. So therefore they are technically bonded. They're technically bonded through whatever you call that. Emotion. They're emotionally bonded to wherever they've come from. That's right.
Yeah, but this is natural because this happens to everything in reality. Just look at how the solar system and the orbits work, you know. We know that it's flying super fast speeds in the middle of the galaxy. We've seen the animation. All the orbits have to catch up. So if entire planets catch up to stay in lock with the orbit, well, then so will gas on a smaller scale. Of course, it's only natural.
It's only exactly what you'd find gas doing if you had a heliocentric model. You're absolutely right, Arwen. If they can do that in that model, we've all seen the animations. There's no reason to believe that gas won't go up, violate natural law. Some of it will come back down, go boom, boom, to keep the rest of the gas pressed on, you know, as it needs to be with weight. And some of them will say, no, but we need to keep up with the lockstep atmosphere that's below us because the ground is actually moving away and we don't want that to happen, so we better keep up with it so that, you know, there's going to be a point in time where people who are asserting that the ground that's moving away from me beneath isn't actually moving away from anybody, there's no net effect, and I want to be the one that proves that for them.
So it's like an orbital push effect.
Just homesickness.
Right, but that would be like the cause of it. But it's like the catching up effect, and it happens with planets in orbits, and it happens with gas in lockstep rotation. So it's like the catching up effect. Could it be like an orbital push? Like suddenly it goes faster, like a push from the other dimension.
I don't know about other dimension. Yeah, fourth dimensional. Yeah, it could be. Yeah, absolutely. Geodesic, why not? So it's the geodesic in space-time that's actually, you know, giving it a path to travel on to keep in lockstep with home below at an increased velocity in violation of the first law of thermodynamics, because obviously it's got an increased circumferential value, and now it's gone higher. You know, the overall value that it'd have to travel to keep up with the ground below is increased. So it's got to increase its energy with respect to the ground, even though it's not bonded. So, yeah, I mean, I would say, yeah, Arwen, there's no reason why any of that should fly. I mean, if I'm a heliocentric complete idiot and I'm on the anti-flat earth side of this argument, then this makes perfect sense to me. In fact, I'm going to say that, you know, you're going to need burning gas particles for that because that's what we've got. So, yeah.
Right, now all we need to do is write papers about this, get it peer-reviewed, and we have actually updated the heliocentric model.
I think we've done very well.
It sounds to me that Arwen is trying to take agency away from these gas particles in his misogyny.
Yeah, what an outrage. Obviously, the ones that go down, go boom, boom, aren't all female.
What?
We don't like your misogyny, Arwen. It's implied. We know. You're not going to try and weasel out of it by pretending you don't know what you've done. What about Darth Particle? What happened to him? Is he still roaming away?
That's the case.
What the?
If that's the case, why can't we demonstrate it here on Earth then?
What, gas pressure without a container? Because it violates second law of thermodynamics. Entropy increase takes place, gas fills space. That's what gas does.
So then we're just talking Narnia now.
Well, obviously, if you're going to explain away a heliocentric model that hasn't got gas going down, go boom, boom, because mass of gas is attracted to mass of Earth with radius value devoid, well, you know, you're going to have to explain it somehow, and gas going up and then burning its bra seems like as good an explanation as any. Why not? What's your problem, Neil?
What about sulfur hexafluoride in a fish tank, like my son was telling me? You put it in there, and it does stay on the bottom.
Does it? So, generally speaking, they transport sulfur hexafluoride in wheelbarrows, do they, Neil? You see, it's a gas, so it just follows entropic law like any other gas and fills the availability of volume.
Maybe your son could maybe, put a weighing scales underneath it and see if you can weigh this sulfur hexafluoride. It must surely have a singular downward vector. if what he's saying is true.
They transport it in like wheelbarrows, though, don't they, Neil?
Well, what he also said was, well, it's not moving in high speeds like you say gas moves. Look, it's just staying right at the bottom, so it is violating natural law.
No, it is still absolutely moving at high speeds. It's impeded by the existing gas that's already there when you displace it by pumping it from a high-pressure container into an availability of volume for that gas. However, the gas itself, regardless of how dense it is, or how heavy they claim it is, by way of their conventions to describe these descriptions to a gas and its behaviour, it's still unbonded, it's still got gaps between it, and it absolutely, unequivocally will follow the law of nature known as entropy, which is to say that with time, it will disperse throughout the gaps in the other gases. Now, it's not got a vacuum presented to it. It's not going to have absolutely rapid expansion into an availability of volume because the availability of volume is already occupied by other gases. So temporarily, you can force sulfur hexafluoride into availability of space. That would be a fish tank with a piece of cardboard over the top of it, displace all of the air out of the way, and then pull the cardboard away to temporarily show that you've got a gas in an area of volume that hasn't yet succumbed to the effects of entropy. But it will, with time, follow that natural law, I absolutely assure you. Otherwise, you wouldn't need to have bought it in a canister, you wouldn't have needed to put the piece of cardboard over the top, and once the experiment was finished, you'd have to go and get a sulfur hexafluoride cleanup crew to remove it, because it would be permanently in the fish tank. Now, that doesn't happen, it just disperses into the rest of the air in line with natural law. It's called entropy.
How come he doesn't seem to ever speak about helium, Neil? Or xenon, or hydrogen, all these kind of ones that have a tendency in concentration to go up when they're in concentration and not after integrating it. Talking about things like CO2 and sulfur hexafluoride is like, it's a weak argument because it can't be weighed in the traditional concept of weight. You need a singular downward vector. So if you can put as much as that sulfur hexafluoride in a room as you want, you still won't get a weight on a weighing scales because those vectors are going in all directions. So,
well, let's face it, Brian, these were all tricks that would catch people that it maybe just coming to flat Earth. These are all little sleights and tricks that they use that keep people wrapped up in the heliocentric mindset.
Yeah, ascribing a downward vector to gas. It doesn't have downward vector. It's got all vectors, infinite vectors, all directions, not just down with weight, in air. Because you're taking the medium that you're taking your measurement scale, that would be solids or liquids in air, and saying, well, the air in air will apply to that convention. Let's stick a scale under it. You're like, no, this is nonsense. Relative to the air, you can quantify something as having weight. Well, that's very useful, and it's applied often. But does that mean that you can sandwich in something that's got a different convention applicable? That would be pressure. Well, no. But you can and will reify your convention into existence by way of this word called gravity, and a utilisation of a 106-year, nearly 107-year out-of-date idea that mass of gas goes down to the centre of Earth. It doesn't. It's just that simple.
Yeah, it's nonsense. And they even make movies called Interstellar, where the whole concept is they're going to figure out what this gravity is. So they're even telling you in the movies that they have no idea because it is nothing.
Well, the M2 value in their assertion that gas go down, go boom, boom, they got gas is M1, and they say Earth is M2. When did they ever measure M2?
They didn't.
We
That's
need
R.
that measurement.
That's R. M2 is R.
Yeah. Yep.
Yeah, you're going to need R for that. Yeah. So to summarise John's point, to assert gas go down, go boom, boom, which it doesn't, you're going to need R for that.
That was good. Okay, you and Neil said it at the same time. We should all say that together at the same time and take the recording of it.
What, you're going to need?
1, 2, 3.
You're
going to need R for that.
That was wrong.
And two.
That was completely out of time.
It doesn't matter. Let's not do. This isn't a pantomime.
three.
Hello.
All
It's not a pantomime. Hello. Meanwhile, right, us pointing out that you're going to need R for that is backed up by a devastating series of arguments that haven't been refuted. The summary being you're going to need R for that. So if you're an anti-flat earther listening and you think that having watched a bunch of chanting Muppets say you're going to need a globe for that has in any way got any devastating arguments attached, you'd be wrong.
Yeah, we have arguments attached to ours.
I'd just like to say something else about the whole globe anti-flat earther claiming that, maybe the claim that air moves in lockstep with a rotating globe, that may not be so much anti-flat earther. That is kind of a mainstream claim. But they claiming that aircraft and that is brought along with it, so that's why we don't see drift and this kind of nonsense. That claim is obviously a load of rubbish. Well, it's all a load of rubbish, but that claim is obviously more of an anti-flat earther claim. But the problem with it is not only should we see drift, regardless of that claim, it doesn't matter. As I said, the plane has to fly through air. But all air travel would require a completely different vehicle than what the traditional airplane. And it would all be flying east to west, because it'd be pointless going west to east. There'd be no west to east flights. And I remember that pilot, Marlene, is it, or Maria? She's a retired pilot now. She worked it out with a friend of hers, who was another pilot, I think it was, that it would take him 17 minutes flying at the right latitude at top speed to make it right around the world if it was a globe. Doing this kind of stuff, something like 17 minutes going against the rotation at the right speed, something mad like that. So, it doesn't matter either way. You would never fly west to east, because it would be a completely pointless endeavor. You'd always fly east to west, and even with the claim of lockstep air, you're flying through air. So the only way to get from A to B would be flying east to west. That means we would constantly see drift east to west, no matter what. But we don't.
Right on. Any evidence? Hello, Adam. Any evidence of the distance to the sun?
No, and afternoon, everyone.
Hey, Adam.
If you assume it occupies a geometric position and it's physical, couldn't you use triangulation to measure it? Well, no, you got to have a flat bottom to that triangle. Never mind.
Well, you'd need the actual size of it, though. Yes, you could do that, but only if you've got the actual size.
But you would still need a flat baseline if you're going to triangulate.
Well, they do. So, I've seen Regeretrix mathematics for doing this, and they start with the flat baseline, measure their angle, and then insert R. So, yeah, they're going to need to start with a flat baseline to get an angle to measure anything. Whenever they assert angular anything measurements, they're starting with a flat baseline. Now, they might tell you after the fact with a bait and switch that they've actually been working from the centre of a presupposed spherical Earth. But if you understand that you're actually taking an angle measurement from the surface, know implicitly that this isn't ever going to work on a globe, because the angle's being taken from a flat baseline. Always.
Bet you they miss that tangent right about now, don't they?
Tangent to what? You're going to need R for that. Black swan. So straight line to the horizon, tangents? No. Your tangent line was your line in the geometric mathematics that was straight and was claimed to be the proof that you got things obscuring things in the distance. Yeah, you're going to need R for that. Black swan. Apparently, according to our anti-flat earth opponents, that's refracted. So no. When we're doing the geometric measurements with angles, which is what sextants do, no, you can't utilise a now debunked by the black swan geometric horizon. They haven't got one.
Well, Rumpus says you have points, right? You have tangent points. You don't need a line. You have a tangent point.
Tangent point is a point on a circle where a line meets it. That's your tangent
Correct.
point. So the tangent line meets a tangent point, but to have a tangent point, you've got to have a tangent line, and that is straight. Now, they need to weasel around this because they don't have it anymore. It's been debunked by the Black Swan. So when you're coming to utilisation of geometric tools that are measuring straight lines and angles, that's just pure geometry, and you've got a curved surface beneath your feet and no straight lines to anything ever, the bottom line of that is that you cannot ever measure an angle on a sphere ever. So if anybody ever asserts that, well, we've got X, Y, Z degrees to the Polaris or to the... No, you haven't, because you'd have to measure that with a flat baseline. No angle assertions are ever going to be taken or measured or claimed from a sphere ever again, ever. That's pretty devastating, given it's done quite frequently for triangulation.
Agreed.
Yeah, that was, I think, understanding that premise, maybe I couldn't articulate it at the time, was why I left the globe. Because I knew that horizon, for it to be a globe, had to be a geometric obstruction that you could measure. And the minute it wasn't, it couldn't be a globe anymore.
Shout out to Mike808 for hitting the super chat. Really appreciate your support. Thank you very much indeed. We had distance to the sun. What did I miss? Any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
It's like the beach ball is, what's his name's greatest magic trick, Mr. Tyson. That has got to be the most ridiculous claim I've ever heard. Center of a presupposed spherical Earth. It's honest.
Do you think they could demonstrate triangles without straight lines?
No.
Yeah, I've heard that kind of jockeyed about, that you don't need straight lines for triangles.
Yeah, I've heard that too.
It's insane.
Well, then it's not a triangle once you don't have three straight lines. Am I correct?
Yeah, thank you, Neil, for stating the absolutely obvious.
Yeah,
But
what's
that's
the name
correct,
of that
yes.
shape?
Go ahead, whoever that was, Mr. Palmer, or Peaceful Warrior.
Right, is there a name for that shape? The bent line triangle?
Spherical triangle.
That's a good name.
They do have
You're
a
gonna
name for
need
it.
R
Yeah,
for
spherical
that.
triangle. It's just
No,
not
you're
a
gonna
triangle.
need R. You're going to need R for that if you're going to cite spherical triangle.
Yeah, you're going to need an F for that. Meanwhile, triangulation doesn't use spherical triangles, it uses triangles.
Is there a mathematics course that we could take that we could learn how to do spherical triangles?
Like geometry.
But no, I don't even think in spherical geometry that you have a triangle with curves. That doesn't make sense.
No, it doesn't. It's a projection.
That's what I'm talking about.
It's a
Yeah.
projection from a assumed celestial sphere onto a presumed sphere on a terrestrial sphere in the shape of a PZX argument that they put out. But it's not what the sextant does. Let me read Harold Jacobi, Navigation. I mean, this will never get old. This height of the sun or of any star in the sky is called its altitude. And so the altitude is always an angle to be measured in degrees and minutes. The point directly overhead is the zenith. The angle between lines drawn to the horizon and the zenith is 90 degrees, or a right angle. It's over at this point. That's how the sextant works. There's a
You can't get a right angle on a sphere.
No, you can't.
So in a book called Show Me the Proof by Stephen H. White, he says, a sextant, a triangulation tool used by mariners, allowed explorers to plot the globe, begging the question, by triangulating the stars with each other and the horizon to ascertain longitude and latitude at sea. So here's a book. It's called Show Me the Proof. The guy is under the delusion that he lives on the globe, but he's talking about triangles and how they work. And he says, a sextant, a triangulation tool used by the mariners for triangulating stars with each other and the horizon to ascertain longitude and latitude at sea. So he's been looking at those side-on view pictures and doesn't understand. Or maybe he does understand, because what are they doing? They're saying, well, we're actually getting the angle from where we can get a vertex, because it's not from the surface, but from the center of a 2D circle. And those are all the pictures. So it's a little sly here. You have to be careful, because they'll show a circle and it's a central angle where a vertex can be achieved, but they're showing you on the surface doing the angle measurement, which it cannot be achieved because it's curved. So catch that trick.
The trick being, here's where the angle's being measured from in this diagram with S1. So at O or 0, you've got this angle being measured. This is where you are with your boat pointing up at the star and gaining its 90-degree position when you've got a flat baseline. So it's the radius of this flat circle that's being described. That would be your area of equal altitude. This is a line of position diagram, in case you're wondering what LOP means. But this 90 is absolutely what you are acquiring from this position. Now the trick is to say the angle actually comes from the centre of a presupposed spherical Earth. You're not measuring it anymore at the surface with a straight line between you and the GP of the star, in this instance S1. What you're actually doing is taking an angle from the centre of a presupposed spherical Earth. This angle isn't being measured here on the surface anymore. That angle's coming from the centre. That's the trick. It isn't. You're measuring it on the surface.
And the surface is what?
Flat. Must be for this to work.
Nathan, you want me to finish those slides that I put up? Because it sounds like you're on S1.
Yeah, if you want.
Yeah, so Nathan explained S1. You need it to be a right-angled triangle as seen to get the line of position. If you go to the next slide, it shows from their own books, from their own slides, that the view of the mariner is this horizon. There is no curve. It's not that side-on view here. And the only thing you have to do here is get your dip correction so that you can get your eyeball on the surface of the water. And the reason for that is because that star in the distance is got a zenith line and a GP, and that's going to be your right angle triangle, the GP of the star to you, your GP. Well, if you're on the boat 10 feet above the water, it's not a true measurement. So you got to get down to the water line. That's why dip measurement's important, to make it geometric. If you go to the next slide, you're going to have a picture, a green picture of a right angle triangle, a 90. So that's where the star is. And where you're taking it is over here in the right side. And there's your angle to the star. And guess what? You need a flat baseline to do that. And this is all in their books. It's a 90. When they said don't say 90, I was cracking up. Everything about it is based on 90. The next slide shows two circles of equal altitudes and the GP of those stars. And where the two circles cross is where the mariner is taking the sighting with the sextant. So he said one of those two crossings. So now he can triangulate because of his position in his logbook tells him if he's up there in the north or down here in the south. He might want to take a third and get a third circle of equal altitude to totally verify where he's at. If you go to the next slide, it shows a picture of a sextant. It says optical instrument for measuring the angle between the heavenly body and the horizon to determine the ship's position. Just break down the words. It's an optical instrument for measuring angles. So let's define what an angle is. Once you define what an angle is, you can't find one with a curved baseline. So it must mean a 90 degree. And it's what they use. So there's no getting around this. If you go to the next slide, they have a little trickery here, but we're going to go past the trickery because they got a curved baseline in that yellow bottom line. But as you can tell, they still say it's a 90. They don't put the box, but they put the angle and say 90 there. So there's the star zenith position and its GP in the center of that circle. And there you are somewhere on the circle, and you have your own zenith, and you're taking it, and it's saying 60 degrees. So what do? 60 minus 90 is 30. 30 times 60 nautical miles equals 1,800 nautical miles is your zenith distance from the GP of that star. So why do you need to know that? Because in the almanac, it tells you where these stars are at every hour, minute, and second of the day, and you can find out where you are based on where they're at. So the important thing is you, the observer, finding your position based on these positions, and you're going to need a 90 for that. I know I haven't could add to that.
And you said 1,800 nautical miles?
Yeah, based on the 30-degree.
That's all flat.
Has to be, because it's a radius, and it's triangulation. It's a right angle.
Doing this on a circle, that's a two-dimensional flat surface. Why? Well, because the bottom angle is utilising a straight flat baseline. Why? Well, because you're going to be getting 90 degrees from it. And what's the other part of that 90 degree? Well, the star's GP. The line directly down from the star to the position on the sea floor. If that's where you're triangulating, it might be overland, but you get my point. There it is on screen. So LOP. This is flat because this circle is a two-dimensional circle, an area of equal altitude. And this is why you need 90 degrees. You've got one straight line. It's just a plumb line from the star down to the ground. Well, then all you've got is you measuring an angle. And your angle is a flat baseline to give you the 90 degree and the angle to that star. That's it. Requires it to be flat. It can never be done on a curved surface. Isn't done on a curved surface. It's incapable of being done on a curved surface. It's beyond the geometric capabilities of this tool to work on a curved surface. Earth must be and is flat. For this to function, furthermore, it cannot function on a sphere. Period.
Nathan, if I may, I'll finish up with this. Primer of Navigation, 6th edition, George W. Mixter. It is on page 229. He's talking about dip. An observer above the surface of the water must lower his line of vision in order to see the horizon, and the required dip of the eye becomes greater as the height of eye increases. This is why all altitudes measured from the horizon must be corrected for height of eye. The sketch shows the dip is always subtractive correction. When the observer's height of eye is about 10 feet, failure to correct for dip would result in an error of about 3 miles in the line of position. So even on the flat plane, you must use this tool properly when you're viewing the natural horizon. You're above it by 10 feet, you're going to be off by 3 miles. So you got to bring it down to have a flat baseline. So you're not off by 3 miles. I'm done.
It's over. Over.
You know, if they like fancy little chants, wouldn't one for that be Earth can't have an R value for that to work?
Correct. Can't be spherical, can't have an R value, can't get a flat baseline to measure an angle, because your measurement of an angle is a straight flat baseline to the GP of the star to give you 90. On a spherical surface, that is not achievable.
Well, I was almost done. The other day we had a show about the long play, the sting operation. Well, it's been working. They have no idea how they fell into it, but that will be shown real soon. Thank you, ballers.
Long con.
That's correct. Long con, you're right. Heliocentrism.
Yeah, the heliocentric argument is a religion that's been sold to you as a way of perceiving the world as it actually is. It's not, it's a model, and further to that, it's a religious belief.
Yeah, but what I'm saying is that we flipped it and played it on them, and they don't even know it's already happened. Soon coming on that.
Indeed. Did we cover all the housekeeping questions?
Believe so.
Cool. That's good. Almost got there yesterday.
You want to give a
Nathan.
shout out for Brian's going to be on Mitchell's show today?
You a guest on Mitchell's show? Yeah, go ahead. Do you want to shout yourself out, Brian?
Yeah, I'm going to be on Mitchell's show tonight, 7 o'clock UK time. We're going to go through the horizon dip correction and triangulation and trilateration. We're going to stick at just basically those two topics. So that's what we're doing, 7 o'clock UK time. I'm not sure what that is in other parts of the world at the moment, but just look for 7 UK in accordance with your own position. You'll get it off Google.
Right. So that's Mitchell from Australia YouTube channel. So be here or be sphere. That's 1900 hours UK time.
Sorry, Adam.
Maybe Christopher Columbus was using the sextant the wrong way, and that's why he thought he was in India.
Maybe he was using it on a globe, and that's why he was so far out.
That's what I mean.
But he can't have been. I know your joke's funny, but he can't have been because he couldn't have ever measured an angle ever if he was on a sphere.
Yeah, that's correct. That's correct.
Just remember, the trickery is that everything is designed to make, this is why it's so convoluted and I don't get into minutia. Everything is designed to make you think it's working on the globe. But the calculations that you end up with is actually because the sextant is measuring on the flat plane. That's why dip correction is required. And you end up where you're supposed to be within a half a mile. And then they trick you with all the minutia, thinking you did it on the globe. And that's what we're uncovering here and exposing, the big lie.
Right, I want to come up with
work.
I want to come up with the phraseology for dip correction between you, me, and Brian, or anybody else who wants to chip in for that matter. So, what Brian's pointed out and you've pointed out is that what you're doing with dip correction is taking it to a geometric flat baseline. So let's call it dip correction to flat, or something like that flows a bit better. In other words, state, every time we say, well, you've got to make a dip correction, what you're actually doing is correcting it to be pure flat geometry. That's what you're actually doing.
Change.
Go on.
Tweak it, because the base is flat, and it always is flat. So when we do the dip correction, the purpose is to ensure we have our 90-degree angle on our flat baseline. So it's to get that angle exactly 90.
So we're doing the dip correction to acquire 90 on the flat plane.
Yeah, I have two. You could say the 90-degree dip correction, or dip for 90-degree correction, or the Euclidean dip correction.
Yeah, but you're not saying. You're missing why I'm saying to do it. The correction takes it to pure flat geometry, acquirable only on a flat Earth, and I want that to be incorporated into that statement about dip correction. So dip correction to acquire 90 degrees on the flat plane we dwell atop, but I want it to be a bit more punchy and a bit more concise. But yes, you're right, to get to 90, that's what we've been saying up until now anyway. I want to make it clear that when we do that dip correction, it's to remove all aspects of anything to do with anything other than a flat baseline, because that's what it's doing, making it geometrically flat.
I like Adams the best because I've got citation after citation from their books saying it's a 90 or a right angle. So let's use the shortest amount of words to explain what a right angle is. Well, you need a flat baseline for a right angle. You need a perpendicular situation. So Adams was fine.
But I want the words flat Earth in there. So you're saying to a flat baseline. Okay, so it's the 90. It's a correction for 90 degrees on a flat Earth.
Yeah, I've got to ensure our angle is 90 degrees to our flat and level Earth.
Perfect. So the dip correction is to ensure you acquire 90 degrees to the flat plane.
Precisely. That's why you do dip, because you're 10 feet above it when you're on the boat, or 20 feet above it. So what's the dip? It's to get you on it. Get your eyeball on the surface, sea level. Don't we measure buildings off of sea level? Well, if you're in the ocean and you're 10 feet above, you're 10 feet above. It's like you're not on the sea level. You got to get to sea level. You got to get to zero so that it can meet up with that box and give you that perpendicular, that right angle 90.
Right. Can you bring up Mitch's diagram that you showed in the pre-show while I explain it on this S1 diagram? So if this angle is being measured from here, so if you say you put a line straight through this O, right? And then you say where it's meeting, that's a better point actually, where this curved angle depiction meets this line, we're going to say that that is the height that the angle's actually being measured from. In other words, pretend there's a little boat here and you're standing on the deck with your sextant measuring this angle. Well, it's then pointing down if you want to consider it, or if this is the horizon in this Muppet Vision view, then you're pointing your sextant down. You're not taking the flat baseline from the flat baseline. You're above it. So you've got to correct for that. You've got to correct for height. That's what the dip actually is doing. The dip correction just corrects for your height above the ground, which is flat. So therefore you correct down to here. And then you're utilizing the pure geometry of a right angle triangle. So you've got a line, like a plumb line, dropping from the star to the ocean, and then your correction from here, it might only be a couple of feet. In other words, you're going to get very little difference in making the correction, but ultimately speaking, to make it pure geometry, you correct to the surface. And what is that surface? Well, to acquire, why are you doing it? Well, so that it's flat, like the surface that you're assuming in this instance to get this measurement. Can't work if it's curved. Why? Well, because the tool you're utilizing in the first instance is measuring an angle. Well, that's two straight lines, not one straight line and a curve. It's two straight lines. So, click across to 10th Man's presentation. This is from Mitchell from Australia. Perfect. You've just gone through them really quickly, but yes, those 3 slides. Go ahead, 10th. You take it away. You're on mute. 10th.
Okay, I'm back.
Okay, great. Yeah, if you go back,
sorry.
I'll zoom it in and we'll go from here.
All right, so here we are, the sun. These are Mitchell from Australia slide. It's got its GP somewhere in the ocean. There you are on the boat with the sextant. You need an angle so that's what you need to get, that right angle. So when you shoot it, you're above that baseline as shown here, and you must make a dip correction adjustment here for it to be exact. That's what the tool's about, because it's an angle measuring device. It's right there in the title, right? So then when you are on top of the boat here, you take the siding, and then dip correction is taking this distance right here and getting it to that flat baseline, as Adam explained. So then now after the corrections that you've done, and there's a little bit for refraction, and you got to make sure your tool is adjusted properly. You go through all those things, okay? But then you got it. And then this is what can put you within a half a mile of your destination. That's thousands and thousands of miles away. And so you got to achieve this situation right here, because this is your zenith right here. This is the sun's zenith, and this is the angle you need. And you can't do this and you be this way with sun in the previous, it won't work here because you're going to be this way. you got to do it properly. It's a right angle measuring device. That's what they all say. So how can you have a sextant that's a right angle measuring device for an altitude of a star or sun work on a curved baseline? It's impossible.
Yeah, you can't. The Earth is obviously, observably, measurably, and navigatably flat. And with that, I'm going to say, if you are watching this on either Nathan Oakley 1980 or Nathan Oakley premiering streams, then stay tuned, as there will be an after show to follow. Unfortunately, if you are watching this live, this is where we bid you farewell. So a huge, massive, enormous thank you to all of you who smashed the super chat, liked, commented, shared, subscribed, smashed the PayPal link, and all that good stuff. Of course, another massive thank you to today's Discord and G Plus panels for making today's live show possible. Once again, stay tuned if you're watching on either premiering stream. I've been Nathan Oakley, and I will see you all in the next video.
When the lid's off, and he actually said the reason the gas is released from the pop bottle is the temperature increase and therefore the inability of the CO2 to remain dissolved in the liquid, right? And I said, so it's not the lid then? He said, of course it's the lid, but when the lid is off, this is it. So once he admitted it was the lid, I asked him to explain, well, if it's the lid that keeps the pressure inside the bottle, what is it that's stopping the earth from going flat? I've asked him about 20 times in chat and he will not answer it. Because without the lid, the pop bottle goes flat. Well, what's stopping the Earth from going flat? They haven't got an answer to it.
That's pretty funny. That's a pretty good way of putting it.
It's bang on true, man. Someone said in chat that Ranty'd done a video, and when I flicked over onto his channel to have a look, it's a 2-minute video, so I'm not going to watch that. There's no point. The point is that if the lid is what keeps the pressure inside the bottle, and you take the lid off and the bottle goes flat, or the pop inside the bottle goes flat, then what's stopping the Earth from going flat? Because it has to be a lid, doesn't it? There's got to be a container, and they won't. Akumo said it was a false equivalence, and I'm like, okay, how is it a false equivalence? I don't see how there's any argument that it could possibly be a false equivalence. Anybody got any ideas to brainstorm?
No, I think it's soda on the point, and they just don't like pop quizzes.
No, seriously, has anybody got any suggestions for why?
I was serious.
No, it's a practical demonstration of gas pressure requiring containment, and then an entropy increase upon you opening that container and giving it an increase in availability. So therefore, you see an entropy increase. You lose all of the gas from the container to the availability of volume that it has after dispersion through the air that's already there. You're just showing entropy increase. There's nothing wrong with that. But if they're saying it's a false equivalence, well, why? Well, because we assume we've got gas pressure without a container in the first instance, Anthony.
Well, that'd make it begging the question then, wouldn't it?
Absolutely. Yeah, without your assumption of a sky vacuum, how can you have gas pressure without a container, is what I asked them.
Yeah.
So he's Kumo's saying it's a false equivalence fallacy. The can/bottle is not comparable to Earth. They bring different variables to the equation.
What does he know?
Like what? Play devil's advocate against me. Somebody come up with an explanation for a false equivalence argument.
You can't. You can't. All you've got to do is segue through whatever convoluted means you can apply from gas pressure in your small scale to gas pressure without a containment at large scale. Now, typically, the way that segue will be employed is with the use of gravity and gas going down, go boom boom at 9.8 meters per second. That's what they will employ. So they're saying it doesn't apply, because if we had an enormous bottle, Anthony, about the size of Earth, then the gas would go down, go boom boom like bouncy balls.
It's not. It's worse. If you follow the analogy through.
Hang on. Just let me respond to that. So if we had a bottle the size of the Earth and the pop that was in that bottle was, say, half full or 3/4 full, that would put trillions and trillions of tons of Coke, right? So that gas is going to be emitting or effervescing out of that 50% full Coke, and it would be filling the gas pressure above it. So it doesn't matter how big the container is. If it's half full of pop, it's half full of pop on the Earth as well, on the Earth scale. So where's that pressure? Why is that pressure not? That doesn't work. That's not a valid counter, I don't think.
No, because you can't have gas pressure in the first place without containment. Correct, Anthony. But I would say no, because we've got atmosphere, I'm going to assume we've got sphere-shaped air. And in that sphere shape there, it's all layered, homogeneous layers of gas. And each layer presses down on the gas below. Because gas does that. It presses down. It goes down, go boom, boom, pressing on the stuff below. So on the large scale, your pop ball, it's got gas pressing from above, keeping the containment of the Coke world up to trillions of tons or whatever you've got in your example.
I'm going to push this for a few weeks and see where it goes. So let's see what they come back with.
I want you to leave your Coke bottle for a few weeks, Tony.
Why?
And come back to see, with the lid off, and see if the Coke's still in there. Will that evaporate as well and reach equilibrium? It will. And this is this is the point with the... if we were analogous to a ball Earth, then taking the lid off is opening it up to the vacuum space. And what you see is gas reaches equilibrium, keeps coming out that's dissolved because there's no longer sufficient pressure above it to keep it dissolved in the liquid. That's why it keeps coming out. Now, if we follow that through to a ball Earth with a vacuum of space, what would actually happen once you've leached all of the gas out of the liquid is that no longer would there be the same air pressure above the liquid. That would then leach off, which would cause the liquid to boil at a much lower boiling rate, which would mean all that would evaporate off as well, which would mean you would be left with an empty Coke bottle.
Well, look at this.
Hold on, is that your video? Hold on, is that yours?
No.
Get it off then.
It's educational use, is it not?
I couldn't give a crap. It's not yours. Film your own Coke bottle. How difficult is it? Educational. No, if it's not yours, it's not being played.
I'll scrub through it then. I'll scrub through it. Is that okay?
If you keep it on pause and scrub through it, I will tolerate it.
Okay. So in this video, it's a time lapse. It's a long. It's a time lapse photography of a bottle of a glass of Coke losing its volume of water over hours and days, right? And at the end of it, he ends up with no pop left in it because it's all gone. So it's like the question is, well, the same thing that's happening to the gas is happening to the liquid. All right, it takes a bit longer with the liquid, but it literally vanishes. I wonder where the liquid goes. Well, it obviously goes into the air. How does it do that? Breaks the hydrogen bond or the bonds that connect the molecules in this liquid, and it all evaporates, right? Well, if it does it to liquid in a bottle, right, in a glass, you can see it literally there. Look at the water level dropping. How long does it take for the gas to do that? I mean, it doesn't take very long, does it? It's seconds. You see? This is a big problem for them because if it evaporates the Coke, then what do you think it does to the gas that the Coke's vaporizing into, right?
Well, I have a response that they'll give if you want to hear it.
Go on.
The reason they'll call it a false analogy is they'll say that there's no way you could get a Coke bottle that big. Gravity would destroy it.
Yeah, okay.
So you can't acknowledge it.
But my counter to that is, all right, give me a bottle 300 miles tall and I'll fill that half with Coke. That Coke is going to be 150 miles tall and it's still going to evaporate, isn't it? So no matter how big your bottle is, I'm still going to fill it with half of the Coke and that Coke's still going to evaporate. And the gas that goes with it.
In your massive Coke bottle, you've got a homogeneous layer of gas above it that's pressing down, go boom, boom. Because I'm a fundy idiot and I don't like natural law.
No, but that's not what we can show, is it? We can show that the bottle evaporates the
yeah, I can. Do you want to know how? I point at the sky and go, there you go.
Yeah, but we can demonstrate that if the container can't even keep the liquid in it, let alone the gas. So I'm going to say you're talking shit because show me a liquid staying in the bottle without a lid on it. Show me that. If you can't show me a liquid, then you can't show me the gas either.
Is no longer contained because it's got the infinite vacuum of space to expand into. The net effect is this liquid turns into gas at a much, much lower temperature because there's nothing to restrain it from evaporating, nothing to hold it back. So now this is no longer, this has lost all of its fizziness, all the fizz has gone, and what you tend to start seeing then is the actual thing boiling, which is what would happen in their world because you've only got the vacuum of space, so there's nowhere to contain it, so there's nothing to contain the liquid, therefore it evaporates and turns into
So
gas.
you couldn't have Coca-Cola in it on their model then, because the Coca-Cola fizz wouldn't exist because it couldn't stay in the Coca-Cola, right?
It would come out instantly because it's the pressure. Because you seal the lid, it's the pressure that keeps the Coca-Cola dissolved in the liquid. It's not.
You know what
You mean the gas? You mean this? You mean hold on. The carbon dioxide dissolved in the liquid. Yeah.
Sorry. Yeah.
So the moccasin now is Coca-Cola debunks Ball Earth.
Well, this is Mountain Dew. But
we're just having fun with you, Glowbeds. We all see you as idiots.
I think their argument just fizzed out and you crushed them.
I asked Phil Bell about 15, 20 times in chat, and he completely swerves it. He won't address it. It's what a weasel.
Gonna get an icy response from them after this.
Do you know, can we have it as a housekeeping question for a month and see what happens? I just want to keep asking it.
No, you've got to speak to Death about those sorts of things.
How do you have Coca-Cola without a lid?
I don't know, let's get 7 of them up here and see what they say.
Is it still called Coca-Cola once it goes flat?
No, it's called syrup water.
Nice one, Adam.
I missed that.
Is it still
Adams.
called Coca-Cola once it's flat? Or is it just called syrup?
Water syrup.
Can I just tell you a little something about Coca-Cola and syrups? So I once had a job at a cinema, right? And on my first day, they explained all the jobs that needed doing, as you do, it's first day on the job. And one of the jobs that they explained that needed doing is something called turning the syrups. Now, a syrup is just a box of Coca-Cola without any water. It's just the syrup, as the name suggests. And it was explained to me that you'd have to, after watering the plants and everything else, just go in, disconnect it, which they showed me, rotate the box, and then just connect it all back up again. Now, doing this makes a horrendous mess. You get covered in this stuff, right? And you do it and you put it all back together and you get on with your day. Now, after a few days, a few of the other staff pointed out, number one, they've got you watering plastic plants. And number two, you don't have to rotate syrups. That's complete lies. They're just getting you to search for tartan paint. You know, they're just filling your time. Now, the reason was because in a cinema, there are massive periods when there's nothing to do. So pissing with the other staff, getting them to rotate Coke syrups and things of that nature was just part of the fun, especially if you've got a new person starting. Just thought I'd let you know on that. It's related
I was
vaguely.
just going to say, rotating syrup. That doesn't seem correct.
Yeah, but it makes sense though if someone says to you that you need to rotate the syrup so that it like stops it gloopifying around the edges, it mixes it all back up again.
At the time, I'd just left home, so I really did not care what they told me to do so long as I got a paycheck, because I just moved out, I was poor, I was a student, I needed the job, and, you know, yeah, rotate syrups, no worries. You know, I'll do whatever you say. I'll give me a paycheck, yep, I'll rotate syrups for you.
See, the big question now, Nathan, is did you get sacked from that job too, and for what reason?
Do you have to ask questions like that, Anthony?
Well, you openly brag that you've been sacked from every job that you've got.
I have been sacked from every job I've ever had. Why do you think I'm a YouTuber?
So did
yes. Let's change the subject quickly away from Anthony's. They say don't tell your friends something you wouldn't want your worst enemy to know.
That's true. Can you tell me that Big Mac that you used to have as a student, economically wise, well, you had to get it? What was it called? I remember you said something about.
Oh no, that's Mac. A recent thing. No, that's what I do because I'm poor now. Oh, you think I did that when I was a student? No. Putting together a poverty Big Mac is something I do now when we're out on an excursion and we need cheap food. So you buy.
Well, run it by me.
You buy a double cheeseburger and a McChicken sandwich. The one that's on the pound menu. And what you do is you remove the layer that's got the salad, the mayonnaise, and the bun. And then you put that in between your two burgers, and then you've effectively got a Big Mac. Now, you can't get sauce, you can't get special sauce. You used to be able to get special sauce here, and then you could literally just turn that into a Big Mac. But short of the special sauce, you've basically got a poverty spec Big Mac and an extra chicken nugget.
Nice. So you could get Mac sauce in the States, so it still works here.
Oh, but that would be perfect. If you can get Big Mac special sauce, you just order one of them, and then you've effectively actually built a Big Mac. The only thing you're missing at that point is the sesame seeds on the bun. But if a Big Mac's $5,
Guess.
if a Big Mac's $5, that I think the double cheeseburger is probably $1.29, and the McChicken mayo or whatever it's called over there is about $1. So $2.29 instead of probably $5 for a Big Mac. How much is a Big Mac? Who knows?
More than $5 here.
Right. So you got
You
pound
buy a
menu, you
Big
got dollar
Mac
menu
meal
though.
at-
So for less than half the
Yeah.
price of a Big Mac, you can put together basically a Big Mac, especially if you can get the sauce. If you don't mind not having sesame seed bun.
They charge you
Try
for the
that.
sauce here now. They people done it so much in my area anyway that they started charging for the sauce.
Bastards.
And you should when we're at one of those display stalls that have touchscreens, because I don't have any people on tills anymore in McDonald's. Me and my wife are there for about 20 minutes. What's the cheapest way to get the meal for the four of us? Trying to figure it out. It's definitely not just by buying a meal. Maybe one meal. You know what I mean? Anyway, this is not a good conversation.
My wife hates it because to get a meal for 5 of us, she can't stand it. It's like over $50. If you just get like quarter pounders, because they're making the quarter pounders fresh now, so they are pretty good. They're back on the grill, but it's over $50 for 5 people.
And not for us. We spend about $10 or $12 and feed 4 people. But like I say, we're trying to haggle every single every penny or every cent in your case out of McDonald's in terms of maximum food for minimum money.
Hello.
Yeah.
Hello.
Were
Yes.
the plants
Okay.
really
Whoever
fake,
that.
Nathan?
Yes. Don't tell us off. I know we're talking about McDonald's.
No. Were the plants
I'm not
really
gonna
fake?
cut
Did
you
you go
off.
and validate that claim?
Hold on. I've got
I
Quantum
was
Racer and
talking-
Sleeping Warrior. Go ahead, QE first, just because we haven't said hello yet. Hello, QE. Sorry, Sleeping Warrior.
Yeah, I said hello. There was one little topic that went by the wayside the other day. I want to get back to it. Because Discord dropped when the subject came up for some reason.
I know. The
it
Wendy's
was-
burger thing. Yeah, go ahead.
Nah, it was abduction, deduction, and induction. It was about the inferences. There's 3 types of inferences: abduction, deduction, and induction. A lot of people confuse inference with induction. That's incorrect. So there's 3 types: abduction, deduction, induction. Does that solve any problems?
I think maybe 5 more times.
Nah, I was finished there.
Can you state the definitions of those?
The definitions of what?
Abduction, deduction, and induction.
Yeah, stay tuned to Ballbusters, and not this Saturday, but Saturday after.
What time?
2 p.m. U.S. Central, 7 p.m. UK.
Thank you.
No, we're back to 8. We're back to 8.
Oh, that's right. I'm sorry. They're back to 8.
You and us, we've both had our clocks changed now, so it's all back to normal.
Sorry about that. Yes, you're correct. I gotta
Technically, it was
change
Mitch
some
that
stuff.
balls the whole thing up first with his initial clock change.
Also, I want to just say something about what Anthony said to you. He said that you got sacked from that too, implying that you got sacked previously before.
He knows I was.
That's not true. I actually cited your words, Nathan. You said you've been sacked from every job you've ever done. I was just asking what was
Thank
the
you.
reason for that one.
Just keep saying it. Thank you.
You've admitted it in your own words.
Yes, to you on a private phone call. Thank you, Anthony,
No,
for
you did
putting
it-
this on
you
my
did it
recording.
publicly about 2
I
months ago.
might have dropped it in. I don't care that much, but that is
Yes,
true.
he told me that. Anthony, you're right. He told me because I said, you must have been a good employee, Nathan.
Not at all.
Yeah, I think it was to you.
No,
You
I
said I've
Yeah,
been
like
sacked
I'm
from every
playing-
job I've ever
Surprisingly,
done.
this is going to shock you. I don't work well with people. The longest job I ever had was when I was a rep, because I was essentially completely autonomous. I was just everything depended on me doing it and no one else around me. There was no manager. You know, I worked remotely and travelled around the world and around the country in cars and planes, and that was down to me doing it and organising it and getting out and arranging the meetings and being at the meetings. And then, you know, people only had to tolerate me for short periods of time, and I wanted them to give me money, so I was ultra nice to them. So that worked out well. I did that for a long time, but I also got sacked from that job too.
Yeah, but we want to know why you got sacked from the cinema, because it's now shrouded with secrecy.
I can't remember. I was 16. I know I got fired. I just can't remember why. I vaguely remember getting into a fight with somebody who owed me money in the bar there, but I don't know if that was the cause of me getting sacked. It was some... I'd have to rack my brains. I was 16.
I think it was a poor choice of words. You mean you don't get along with bosses, not people?
Well, you could say that. Yeah. Let's go with that.
No, because that's why I was self-employed all my life. I wanted to do the fast way, the good way, my way, and everyone was slowing me down. I said, forget it, I'll go start my own business.
No, you're right. It was, technically speaking, just bosses. And at one stage in my career, I thought, maybe I should be the boss. Maybe that would solve the problem if I was in charge. I was the biggest bastard you could possibly imagine when I was a manager. Just evil.
I'm good. When I run a job, I put everybody on their strengths. I don't put anybody on their weaknesses. If you patch the floor well, you're patching the floors. If you're good on seams, you're doing the seams. If you're good at linoleum and vinyls, that's what you're doing. The other people try to put you in positions where you're not that strong.
Well, I was a manager in hell, in a den of thieves.
I can't deny that.
Pawnbrokers. That's what I managed. Evil places. If there are any pawnbrokers out there that I'm offending, I don't care.
Where's all the ballers anyway? Where's all the anti-flat earthers?
Who cares?
Did we really annihilate
You
them
guys
at
really
the head?
do concern yourself an awful lot. It's like the door's open, right?
I like to get them smacked.
Right. When somebody wants my attention, I'm like, the door's open, just walk in. Now you guys are sat around the bar, talking to me, in this case the bartender, if you like, and going, where are the people we can punch in the face? And you're like, well, maybe there are other bars. Just go and find them if you're looking for a fight. Now, don't get me wrong, I don't want to entice fights in this bar. Now, don't get me wrong, they do break out here. You can spend all day justifying why and how and the wherefores of the fight itself and why it broke out. But why? If you're going to chase this sort of action, like Anthony does, go out and poke the bear. If you want a few tips on how to get that to occur for you, just ask Anthony Riley. He's a dab hand at it.
Can I just correct the analogy that you gave, Nathan? You shouldn't be compared to the bartender. You're the slumped old guy at the edge of the bar that's been there that long that you no longer give a shit.
Yeah.
So when we come in,
no, that would be true.
Sit next to you.
That would be true.
And then talking to you, you're the guy that stinks a little bit, and he's got a bit of too much beard growth, and he doesn't look. He's unkempt. That's you.
Right.
You're not the bartender.
No, I think I agree with you. That would be me. Slightly stale piss, reaching over the bar, getting told off by the barman, and then when someone says, "Who the hell's he?" they go, "Yeah, he actually owns the bar."
yeah, that's it. Yeah.
Unkempt. What's unkempt? There's no M in it. It's unkept.
Spandau Ballet
I
reference.
don't know why all these people in Discord keep on referring to the scientific method as the QE method. I'm sure you're flattered by that QE, but the scientific method was here long before you were.
That's a damn lie.
No, it wasn't. QE started it.
That's right. It's mine.
Man, you are so smart. I wish everybody was like you.
So do I. So does my mom.
I mean, I didn't technically learn at uni that QE did the method.
He's exciting himself right now.
Three more people, maybe four more. Four more.
And they're all crying.
Try that once more, Chaos.
Can we have a volunteer to read what I've got on screen?
I said I'm schooling all these fools in Discord chat right now, and they're all crying. It's me versus 4 or 5. Again, they're all crying. I'm winning. Thank you, QE. Thank you, scientific method. I love you guys.
Go ahead, Sleeping Warrior.
Can we have a volunteer to read what I've got on screen for the benefit of John in Discord, please?
Yeah, I see it.
Unkempt, especially of a person.
It is. There is an M in
having
it.
an untidy or dishevelled appearance.
That's where the M is.
Don't mess with Anthony.
Hold on, was that British English?
Never mess with a lawyer and words.
Yeah, it was an English phrase. Unkempt. If you, it's dishevelled. That's exactly what it's a tramp. That is the word to describe.
It's a. Why'd you go to the?
I understood you.
Why'd you go to the German dictionary, Anthony?
Because the English one didn't work. I picked the one that suited my argument best.
Hold on, was that the German dictionary? Seriously?
So you called Nathan a tramp?
Yes.
Yeah, if I react to that in any sort of negative way, I'll never hear the end of it. So the only way to do this with friends is to immediately embrace the piss take, which is precisely what I do. I'm just giving Arwin advice, actually.
Exactly, Nathan.
That's the way to do it. Because we all know.
Are you talking about me again while I'm doing groceries?
Yeah, if I call you fat, Arwin, just to keep this going, because I was being dead serious. If I call you fat, right, the way as a friend, right, I'm having a jab. Let's say you had put on a few pounds. You must embrace that immediately. If you don't, you will become fatty boom boom for the rest of your known life as friends with us.
Correct.
It's like we did with Bilu, isn't it? It's like we did with Bilu. They started taking the piss out of us with Bilu, so we adopted Bilu, and then he became our friend, right? So they couldn't use it against us anymore.
Or equally,
well, you got to agree real quick when you're getting your balls broken. Otherwise, they'll keep getting broken.
I'll give an on-topic example. So Anthony knows where I will be assessing my own performance, and I gave examples of this yesterday. So after that dude came in and debated with us on Monday, I believe it was, I reviewed it that night and went, I missed that. Well, I missed that. Didn't give it much thought other than, would have been good if I'd addressed all of those things. Notice it's just come up earlier about induction and yeah, that's the same point. But after a snooze, I woke up to a message from Anthony going, you let that slide, didn't you? That's what I woke up to from Anthony. Now that, I know Anthony knows when and how to get between the ribs with his little jab, and that did. Now, I told him it did. He knows it did. That's why he did it, right? But my point is that in that instance, I have reacted. I've gone, well, fuck you. In other words, he's gone, so that gets under your skin. Right, I'll remember that button. In fact, I'll make that button bigger.
Let's just put this into context, right? That show was, 90 minutes long because you did an extended version, right? And my comments that summarise that whole 90 minutes, and I've got it on screen, it says, good show today, but you let him get away with claiming that science is inductive. Only the hypothesis is inductive. The experiment to prove it is deductive.
Wrong. Incorrect.
Yeah,
Hypothesis is not inductive.
Yes, it is. Do we need to get another citation up for you, John?
No, it's not.
This has worked out better than I expected. Everyone except Quantum Eraser, please be. Everyone except Quantum Eraser at this moment, and then Sleeping Warrior, please be quiet for the foreseeable future. Thank you.
Induction is based on probability or likelihood. Hypotheses have nothing to do with probability or likelihood. Game over. Thanks. Got to flip my eggs.
Running away, Anthony. He's just claiming he's got to make breakfast. He's running away.
I've just typed in scientific hypothesis, inductive, deductive to see what we get. The inductive approach begins with a set of empirical observations, seeking patterns in those.
Empirical observations, you say? That sounds familiar.
Hang on a minute. Hang on.
Keep going, it gets worse.
I know. Hang on. The inductive approach begins with a set of empirical observations, that's the phenomena, seeking patterns in those observations, that might be the hypothesis, and then theorizing about those patterns. The deductive approach begins with a theory, developing hypothesis from that theory, and then collecting and analyzing data to test the hypothesis. That's the first citation.
You're inducing.
Yeah, let's see what it says. The main difference between inductive and deductive reasoning is that inductive reasoning aims at developing a theory, whilst deductive reasoning aims at testing an existing theory. Inductive reasoning moves from scientific observations to broad generalizations, and then deductive reasoning's the other way around. So when I read this last time I read this, it said that the hypothesis and the observation stage is inductive because you're inducting what you think might be the cause. And then the experiment to prove or disprove it is the deductive part. You either prove that it is or you prove that it's not, but you deduct from your hypothesis whether it's one or the other. That was the way I understood it.
No, trying to figure out the cause, your assumed cause may be deductive or inductive, but formulating the hypotheses is abductive.
Scientific method uses deduction to test hypothesis and theories. In deductive inference, we hold a theory, and based on it, we make a whatever that is. The point is that
Well, hold on.
That's wrong.
You don't have abduction. It's not a dichotomy. Why is it not mentioning abduction?
Don't know.
And can you look up the definition of abduction?
Let's answer that.
to see if it applies?
Why isn't it? Well, because these are all mainstream references that Anthony's getting, and these mainstream references are going to be very much in line with the pseudoscience version of what science is. That's why.
Live science.
Yeah, I mean, you don't see it though. Like, have you not seen the issue with what you were reading from the looking at patterns, and then all of this makes. I don't know what that has to do with establishing cause and effect relationship. So when they say deducting something, well, they're deducing what something potentially could be. Well, that's not science, is it?
Yeah. At the experiment stage. Yes. When you're deducing whether or not your null or your alternative is correct by validation, i.e. vary and manipulate the thing you think causes it and see if it causes it. Well, that's deducing which is true.
Yeah, so look at this. It says inductive reasoning.
Mute, Eli. Eli, if you're not talking, can you pop yourself on mute?
Inductive reasoning. Let's get rid of that later. Inductive reasoning is the opposite of deductive reasoning. Inductive reasoning makes broad generalizations from specific observations. So like microphones, drops, right? Basically, there is data, then conclusions are drawn from the data. This is called inductive logic, according to Utah State University. Whereas deductive reasoning is a basic form of valid reasoning. Deductive reasoning or deduction starts out with a general statement or hypothesis and examines the possibilities to reach a specific logical conclusion according to California State University. I don't like that. That's not
incorrect.
Good. It's not narrow.
Incorrect.
Objection.
Incorrect.
Go ahead, Q. You're back.
That's incorrect. Induction has nothing to do with science whatsoever. Karl Popper. Number 2, I told you, induction has to do with probability or likelihood. Period. End of story. Show me a hypothesis, probability or likelihood hypothesis or experiment, or you're done.
I think we're actually agreeing that it's deductive. That was the bit that I said to Nathan. You let him get away with saying that science was inductive, and it's not. It's deductive. That was the point I said to Nathan.
I let him get away with it. I didn't. I wasn't there.
Well, you might go and do a load of. Sorry, Tony.
Go on.
I'm trying to put it together a little bit, really. You might go and do a load of preliminary stuff. Some of that may be inductive. You're not really knowing what you're doing. You're just doing stuff and recording. With all that research that you've done, you may have an abductive thought in some of the correlations that you see. You will then go on to use deductive reasoning within your hypothesis and experiment to test that abductive thought that may be initially born from those inductive messings about.
Which is why Hillbilly Blue Balls has got a problem in his test, because he's got a demonstration showing an actual acceleration, but he hasn't got a cause to do it. So deducting that it isn't gravity because that's not a force, it isn't the curvature of space-time because that causes an apparent acceleration rather than an actual acceleration. By deduction, there's only 2 things that are left that's possible.
Hold on. No, first apply the method where he hasn't.
Observe natural phenomenon.
Precisely. Who was that? Was that Brian? Ask that again, please.
Yeah, that was me. Observe natural phenomena.
What's his observed natural phenomena, Anthony?
Don't know, but you just totally destroyed my point.
But your point was into the weeds of his begging the question of a test, you said. Well, we're talking in scientific context, most specifically, getting right down to the nitty-gritty in terms of the logical inference prior to experimentation and your deductive test that will leave you with one outcome. But that is based on the method, although it hasn't been detailed thus far, and you're into the weeds of whether or not it'll prove something that you're about to detail in terms of the cosmos. No, stop. Observe natural phenomena, please.
That wasn't what I was going to say. You should have let me finish.
Oh, okay.
I was going to say that I was going to say that by deduction, we can establish what was the cause of the acceleration in Hillbilly's blue balls test. Because we know gravity is not a force. We know the curvature of space-time only causes an apparent acceleration that we perceive as an acceleration, but you got actual acceleration. So by deduction, we can prove that one of two positions is true. Either there was another variable that he didn't control, and he insists that he got all of his variables perfectly controlled because he used an earth strap and he did this, that, and the other. So there's only one thing that we can deduce left, and that's him. He's done something to make that do that.
I was right. You had completely missed my point. What you're describing is is into his territory and his conclusions of what it could cause, and you've strapped an extra one on and described it as almost having scientific validity in terms of what's going to be the conclusion at the end of this quote-unquote test. But what you are pulling apart from within that paradigm is where, you are too involved with begging the question with them. It's the same exact process every time. What's the phenomenon? Brian's already asked you, and you're like, no. Within their paradigm of begging the question of what's going on here, what are we observing here?
I was just using the deduction process to demonstrate that we could deduce.
No. I'm only done with them. I'll do my promise, and then you can have him. The deduction part is the deduction of either if A then B or if A not B. Which one? Yeah. That's what you're deducing. But that's
but the problem.
But that's A, independent variable, and B, dependent variable. So we're going to know what. Yeah. We're going to need to know what B is first.
The problem is we've deducted all of the possibilities out from it, haven't we? Because we know it's not gravity, we know it's not bendy space-time, we know it's not his control variable, so there's only him left to deduce.
He's still doing it. Adam, have at it. You're not getting through to him.
You can only deduce from the results of your valid experiment. You can't deduce anything from a crock of crap. So, does that make sense? You can only use your deductive reasoning on your data. And then that data has to have validity. So, as Brian says, it's got to start with a naturally observed phenomena. And you then experiment around that. They're not doing that. So, whatever the results are, you can't deduce anything from the results other than it isn't science.
Well, the only question that he needs to be asked is, what's the effect he's claiming, and where do we observe it? And what he would say then is the effect I'm observing, or we observe, is gravity. But gravity is not an effect. Gravity is a name given to a claim.
Actually, technically, by definition, it is an effect.
Really? Where do I observe gravity?
No. It is an effect claimed in mathematics, but that doesn't mean we observe it.
No, it is defined as an effect. So you could have the effect of being the curvature of space-time. That is the definition.
No.
Yeah, but where do I observe it? If it's a real effect, where do I observe it?
Exactly. Where do we observe that?
Let me qualify for Anthony. In the same way as I can describe the time dilation walking through the wardrobe as an effect. Right, Anthony?
Yeah. No, that would be the cause. Walking through the wardrobe would be the cause, wouldn't it?
No. The time dilation is the effect, though. So I can say there is an effect that is defined in terms of the time dilation, cause of walking through wardrobe, if you like, but that isn't what we're doing. We're saying, what's the observed phenomena? What's the B in my if A then B statement? What's the effect we're observing? Well, in this case, you're saying it is defined as an effect. Yeah, and time dilation after the cause, walking through wardrobe, is also defined as an effect. But Brian's question is, where do we observe that effect in reality? And the answer is we don't.
Well, that's what I was trying to say. In the answer to that, it's in the maths. That was the answer.
Right. Okay, back to the original point before... Sorry, Brian. So, when you're talking about what Hillbilly Blue Balls has done, and that effect that's apparently being experimented on only exists in the maths, what's the effect in his physical apparatus, then?
That's exactly what I was going to say.
There's an acceleration.
That's what I mean. If I ask him, what's the effect that you're claiming, to have seen, and where do I see it? He's going to say gravity, because he's not going to talk about Albert Einstein's theory of general relativity. He's going to be referring to a force of gravity, because that's what he thinks that he's measuring with his apparatus. So at that point, if I ask him for the effect, if he says gravity, then he's giving me a claimed cause. But I'm looking for the effect. So I'd have to drill him for, but what's the effect? And he's going to say things fall to the ground. And that's where we have to start then. Okay, things don't fall to the ground. What things fall down? What things don't fall down? Why do the things that fall down fall down? And at that point, you're into relative density. But that he never get, like, his side never gets past the people we deal with. They don't get past. They don't get to the actual effect. You ask them what's the effect, and you say gravity. That's what they say, gravity.
Yeah.
But that's
so
not
back
an
to your,
effect, that's
I'll
the
put your
word.
question to Anthony, to you then. So where do you see that naturally occurring phenomena, Brian? When they just say gravity, or where do we see that happening? What is it? What's occurring?
I never see it. It's not an effect you can see. I don't see it's never been defined. I don't know what it is they're talking about. I don't see gravity.
But Anthony can define an effect. He did an experiment to qualify the cause of it. What was the effect that you observed, Anthony?
An acceleration.
Was there a particular vector?
Yeah, in the anti-gravity vector, and a controlled magnitude that I controlled.
Anti-gravity? What's gravity?
He's just being facetious. Some things move up, some things go down, some things stay neutral. That would be the effect.
I know. I'm not trying to be awkward about it. I'm just saying, when you say anti-gravity, it means you're giving gravity a reality. There's no hypothesis put forward or hypothesis test that adhere to the scientific method ever for the thing they claim is gravity. And that's why they keep changing the claim of what gravity is. They keep changing the description because it doesn't exist. So they keep on trying to come up with a different version of it. They're coming up with a third version now. The point is that you ask, what's the effect? Einstein gave a cause and then claimed gravity was the effect of this cause. But he never showed this effect. He just claimed it was an apparent effect of acceleration. What's the cause of the acceleration then? The curvature of space-time. So it all goes into mathematical nonsense. Prior to him, there was claims of a force of gravity that caused things to accelerate.
That's not right. That's not right.
Prior to Einstein, there was a claim that there was a force of gravity causing acceleration.
Yeah, but he did predict that there would be the cause of the effect would be able to be demonstrated in a solar eclipse, and it was done in 1919 by Eddington, right?
But was that an experiment that adhered to scientific method?
No, it wasn't an experiment that adhered to scientific method, but it was a prediction he made. And then when it came to the eclipse, they observed an effect, and the effect.
Yeah, but that's not what happened. What happened is he gave a cause, and then people went out looking for effects to fit the cause that they believed, to fit the thing that they believed existed.
I agree.
The same happened with the Pound Repke and Hefeli Keating. It's the same thing. They're trying to conjure these effects.
Hang on. The problem is he made the prediction. They went out and tested it by observation only. And then when they observed the phenomena, then matched the results to it, they correlated that it must be caused by the curvature of space-time.
And not refraction then. Refraction wasn't taken into account. And the other times that this same thing was done, and it didn't match what Einstein claimed, we forget about all them. So this is the problem. This is the problem. When you ask them, what's the effect I should observe? Gravity. What is this gravity? Right. What's the effect? They can never give you an effect. The best they can do is say things fall to the ground. And even in the current description, it's the ground is coming up to meet the thing because the ground is in the object's free fall future. This is show me the effect in nature.
The whole reason they need gravity is to explain or justify the stuff sticking to the outside of a ball flying around in space. They need some kind of explanation for why stuff isn't expanding out the way it would be expected to.
I would like to point out that Anthony did give an observed phenomenon, but he gave it as proof when he said that. Right. His observed phenomenon was the Eddington observation. They observed something.
Well, it was the change in the position of the expected position of the stars during a solar eclipse. That was the prediction, and that was the claimed evidence.
No. That's the observed phenomenon. Now, how did they vary and manipulate that?
Well, that's the problem with it, of course. That's where they accepted that it was science and didn't realize that it was observation-based only, and it was correlative only, not experimentally validated, right?
Yeah, as I said, Einstein gave him a cause, and just like the Pound-Rebke and the Hefele-Keating demonstrations, they have that was the only natural phenomena they had, and there was other people that took that same phenomena, and it didn't match Einstein's predictions. But because Eddington and Einstein were somewhat connected or something, I remember reading something about it, they accepted it. But what about the other times when it didn't match it? You know, the Pound-Rebke and Hefele-Keating, what were they? They were induced things. So they had to come up with the effects afterwards.
Hang on. The Hefele-Keating one, for those that are unaware, is the planes that were flying east and west. One plane flew east, the other plane flew west, went around the Earth a couple of times apparently. And when they came back, the atomic clocks showed a difference. And one of them said that, well, one of the difference was alleged to be put down to time dilation, right? And that was essentially that was claimed to be proof of or scientific proof of validation of science. Einstein's theory.
Sorry, time's a concept, right?
But it's an interesting phenomenon.
Hold on. Time is a concept. How do you dilate a concept?
Well, this is the question, because they based it on the frequency rate of the cesium clock that beats it whatever given rate it is per second.
Yeah, what he's saying is time is not a clock.
At me all the time.
What he's saying is time is not a clock, Anthony. Like a football field's not yardsticks. It's a very simple concept. And by the way, Eddington did his quote-unquote experiment in 1919. I thought the general theory of relativity was published in 1916. How's it a scientific theory in 1916? Without experiment?
Both back off your mics, Mr. and Mrs. Plosive.
Nobody said it was a scientific theory.
Then how could there be an experiment validating it 4 years later? Or
That's
3 years
the claim of science, isn't it? They claimed that Eddington supported it by observation-based results. That was the claim of science. That's why it's
observation-based results?
No experiment, John.
They came, they saw, they conquered.
I think they were empirical observations, were they not?
Not empirical, no. They were observational.
Empirical.
Sounds a lot like observations at the bottom of ships disappearing stood there for a long time until we found out what was really happening.
It doesn't matter, because my son uses that so-called experiment all the time when I'm talking to him about flat Earth. He brings that Eddington thing up.
I can do this backwards too and prove unicorns if you would like. Because unicorns are invisible, they cause entropy. And because we observe entropy, unicorns are real.
Yeah, unicorns must exist because entropy exists, yeah.
What was the unicorn's name? Was it Bingo?
No, Bongo. These are tricks that they use. We know that.
Well, as I said earlier, Einstein came up with the cause before there was ever effects. And after that, outside of the Eddington observation, all these other effects were all induced through man-made apparatuses with the cesium rate decay and other nonsense, like with the Pound-Rebke. It's all like we need to make up effects that will match the cause we were given. Like you're supposed to start with an effect and end up finding the cause of it, not the other way around.
Also, because unicorns exist, they will affect cesium clocks when moved through space. If cesium clocks are affected when they move through space, unicorns are real.
Beautiful affirming the consequent formal logical fallacy. Thank you very much for that.
It's okay, Nathan. I caught the joke.
Hey, can you post that song, John? I really like the way the tune is.
Hey Neil, it looks like Neil, it looks like they're building that building a little bit wonky. You better go and tell them to correct for the Earth rotation because it looks like it's leaning.
Yeah, it's the Brooklyn building. It's weird. It's like looks like steps, but on an angle.
They've obviously forgot to take into account Earth rotation. Go and tell them to correct the maths.
Yeah, I'm going right there right now. I'm going to get them. It's actually right off the water, Brooklyn. Wow, they have built this neighborhood.
Extremistus, why don't you tell us how the Eddington observation was manipulated? What did he do to his eyelids? He went on deafened immediately. What a puss. You know what? I should kick your ass out of here for that.
Kick him out.
I'll
Because
just
he
delete your
shouldn't be
post.
there. Taking up space.
Neil smells blood immediately.
Yes, I'm hungry for a fight.
Nah, I was just about to berate him. Come on.
Tables really have turned, haven't they? I mean, it's almost comical now.
Wouldn't you have thought somebody would have noticed that the architects of that building forgot to account for Earth rotation, and that's why they've built it that way?
He kept moving on him.
Yeah.
Is that building named the Coriolis or what?
The Coriolis at 1432 Elman Street.
15 Eagle Street.
What's the name of the building, Neil?
He doesn't know.
Don't know yet. I'm almost there, but I think I'm doing work there.
Alrighty, well, that's good to know.
Well, maybe, Anthony, a good question for Hillbilly Blue Balls is, for Blue Mara Science, is where in his apparatus does he account for the curvature of space-time? Do you know what I mean? It's like if you want to just, ask him ridiculous questions, because if you try and have any normal conversation, it's just going to come back to what's the effect? Gravity. That's all that's going to happen.
Yeah, I know, but every time I have him on it, basically he won't say gravity is now Newtonian when I ask him. He always says it's the curvature of space-time. And then I say, okay, so how did you manipulate the uneven distribution of mass to bend space-time? And he said, by moving it closer. I'm like, okay. And then when it moved closer, did it cause an actual acceleration or was it an apparent acceleration? And he says, an actual acceleration, Anthony. And I said, right, well, the curvature of space-time causes an apparent acceleration, not an actual acceleration. We clearly have one. So that's not explaining the phenomena. So did you not control all of your control variables? And he'll say, yes. So, well, it only leaves you then. You must have done something because no one else explains it. And he just goes mad.
Well, couldn't he claim that the fourth dimension is the actual natural world and the third dimension is a projection of the fourth dimension?
But then,
I mean, if you're going to get silly with it, you might as well just rock it out,
But then he's got to explain then that the actual acceleration that we see is actually apparent acceleration. It's not actually moving.
You didn't hear me. There is no actual acceleration. It's only apparent because you're existing in a projection of the fourth dimension.
Yeah, that's what I said. That's how I addressed it. So that means he's got to explain the actual acceleration as apparent observation. It's not actually moving at all. He's then got to go against his own observation test, right?
Yeah, that would be if he wanted to stick with Einstein, that's what he'd have to do.
This is why he goes mad, because he can't have it. Because for him to get Einstein correctly applied, it's got to be apparent acceleration, but he demonstrates actual acceleration that requires a force. So then there's not enough left unless he's failed to control his variables. And if that's the case, then it means that you haven't controlled all your variables anyway. It's unreliable. And if you have controlled your variables, it must be you that's done it then. Somebody's done it somewhere.
In his mathematics, did he use M1 value and an M2 value within the Cavendish apparatus?
Show us your thing, Neil.
It's a baller that built it because look, it says new 20. Then in parentheses, it got 30-story building. So what is it, 20 or 30? Gotta be a freaking baller.
But if he's, using this Cavendish circus sideshow thing as proof of his position, he's calculating how one ball M1 will affect the other ball M2 and cause the torsion bar to move, right?
Well, I don't know how he's done it. Well, I have no idea.
I don't even know.
Is he not showing his work?
I don't know. I haven't paid that close attention to it. I'm just trying to establish what was the cause.
I don't even know why you're even talking to a guy who brings gas in containers and then says they're not contained.
He's still got that video up, I actually had somebody excited.
I just don't get it. I don't even know why you're still even bothering with this guy.
Because sometimes I wake up and I think these guys need to be challenged, and other times I think, it's a total waste of time.
So they're mentally challenged already when bringing gas in containers and saying "see," and they show it in another, and they're not mentally challenged enough.
Yeah.
God, let these people die a quiet death.
It's hard to let them die a slow death when it's so much fun berating them.
Yeah, but they do that for attention. You're giving them what they want.
No, this is what they want. No. This is what Neil and I forgot your name, Chaos, I think it is. They can smell blood in the water. We said the tables had turned 2 years ago, but the people around us, it's going to take a little while for them to go, you know what, you're right. These people are all cowards running away from us. In other words, they smell blood now.
Well, the cowards running away from us, but they pretend that it's because you're an arsehole. But it's just such a convenient excuse. But listen, the reality is Jose's show only exists so they've got a church to go and preach in. That's the only reason it exists.
There's many ways to look at this. The way I see it, and please feel free to respond. The way I see it is they are starving for attention, and it goes something like this. You know what? I know I get hammered when I go there, but at least I get noticed. I'm going there. I know I sound stupid when I go there, but I need attention, so I'm going there. And on this side, I can't wait till they come here so I can hammer them. So you have no idea what you're doing when you look at how people come, and the normal behavior of people is self-preservation. They've given self-preservation up just to be noticed.
Wow.
Yes. But that's how it works, A dream only keeps afloat, stays alive if people know it is there, if people dream the dream. Now, how they respond to the dream, whether they discard it or they love it, that's another matter, right? So, yeah, spreading the dream has a higher priority than self-worth to anti-flat earthers. Nah, I'm idolizing it too much. That's more Baldwin. They're not even like that.
The only reason I bring that, hold on a sec. The only reason I brought that up to you, Anthony, about the mathematics he would be using is because they think they have a religion, or they don't accept it's a religion. They think they have reality based on measurement, right? And if you can get him, just getting to the point where he's talking about M1 in relation to M2 because he's still on some Newtonian kick, ask him how he measured M2.
Yeah.
But they're given permission, though, to do that. So, they don't see an objection there anymore. Right?
They don't have a problem with not having measurements? I think they do. They're ignoring it.
But you don't need measurements. You got math.
No, just chant. Just say, you're going to need a globe for that. And then not having measurements cognitively works for some reason.
But they can calculate it in a model, so it's real.
Yeah, just
how do you calculate? What are you calculating if you don't measure anything, though? It's nonsense.
Neil, stop, Neil. Go back to the front of that truck, Neil.
We're having two things are going on right now.
Just go to the front of the truck. Show us the cab. Look at how pretty those cabs are compared to the shit that we get. We get a flat-fronted block at the front like a brick, and they get something that resembles something like prestigious. Look at that. It looks great. I think that looks amazing. What do you think, Nathan?
With that, I'm going to say a huge, massive, enormous thank you to both Discord and G+ panels for making today's after show possible. And of course, a massive thank you to all of you in either Nathan Oakley 1980 or Nathan Oakley Premiering streams, hopefully smashing the super chat, liking, commenting, sharing, subscribing, hitting the PayPal link, and all that good stuff. Also, below this video, you can get £50 for swapping your UK electricity supplier to Octopus Energy, and this is a particular note if you drive an electric vehicle. I've been Nathan Oakley, and I will see you all in the next video.